Today, I want to show you guys how to do a hard double integral. Here, we have cosine of x over y plus 1. And notice that we have dy going first. So, we are in the y world. But y is in the denominator, and that's inside of cosine. So, can we integrate that? No. So, the best bet is to switch the differentials, right? That's the key. And of course, that means we will have to take off the boundary. Okay, the best way to do so is to draw pictures. So here we go. I'll do it on the side to make it super clear for you guys. Firstly, we have dy. So this means y equals square root of 1 plus x. That means just the square root of x graph, but you move to the left 1 unit. So it will be something like this. This is y equals square root of x plus 1 or 1 plus x. And then we have to go up to y equals 2. So let's say here is where 2 is, and I'm just going to kind of do a dashed line a little bit like this because I haven't determined that region yet. Now dx, so that means x is starting at 0. This is where my 0 is. So this is the starting of the x. And then we are going to go up to 3. So that means x equal to 3. Is this 3? Yes. When x is 3, if you put it here, 1 plus 3 is 4, in the square root is 2. So they do intercept right here. So the region that we're talking about is actually this part right here, like this curvy triangle thing. Right? So this is y equals 2, and then we have this curve, and then this is that. Okay. Now, if I want to switch the order of integration, I want dx going first. Right? So the inside stays the same. And then dy next. Dx, that means we have to look at the starting x value, which is at 0. Good. Now we have to go up to what? Not to 3 though, because the x from here to here, from here to here, it changes depending on what this curve is, right? We have y is equal to square root of 1 plus x. I need x in terms of y. So square both sides, we get y squared equals 1 plus x, and then subtract 1 to both sides. X is equal to y squared minus 1. So that's for this curve here. Get inside from here to here, and then from here to here, and so on. So we go from 0 to y squared minus 1. And to continue, for the dy, the starting y value here is what? When x is 0, plug in here, square root of 1 is 1. Up to what? 2. So the starting y is 1 and the ending y value is 2. Aha! That's much better. Now, do this inside out. Integrating cosine x over a constant in the x world. What do we get though? Well, I'm just going to write this down for you guys. The outer integral stays first. I'm actually going to give you guys a quick example because I know this might be super confusing, but it's actually not so bad. You just have to get used to the idea that y is a constant in the x world, so it is y plus 1. Imagine if you have to integrate cosine of, let's say, x over 3 dx. What's the answer for that? Well, what's the integral of cosine? Positive sign, yeah? And since this is x to the first power over a constant, you can keep that. But you will have to divide it by the derivative of the input, which is 1 over 3. Divided by 1 over 3, it's the same as multiplied by 3. So that's what we have. Same thing here. Integrating cosine, we get sine. X over a constant stays. But we will have to divide it by the derivative of this. The constant is 1 over y plus 1. Divided by that, it's the same as multiplying by that. The multiply by the reciprocal. It's the same as multiply by its reciprocal, which is the same as multiplying by y plus 1 here. So it's the same thing. The y plus 1, it's like the 3 right here. I know I didn't put on the plus c there. Anyways. So that's the inside, and we still have to go from 0 to y squared minus 1, and then still have the dy after that. Now, if I put y squared minus 1 into x, remember, I just have to plug in this into x, not to the y. Okay, this right here, the outer stays the same. The y plus 1 stays the same, but we still have sine, and that will be y squared minus 1 over this y plus 1. And then I have to plug in 0. Sine of 0 is 0, so the second term is just 0. That doesn't matter. And we have dy. Now, for this right here, y squared minus 1 over y plus 1, this is really nice, huh? Because we can factor it. That's y plus 1, y minus 1. And the y plus 1 cancel out very nicely. So, we will get the integral from 1 to 2, y plus 1 times sine of y minus 1 dy. And now we just have to finish that, and that'll be it. Now, the key to do this integral is we will have to use integration by parts. But before that, maybe let's do a u sub, because we have y minus 1 and the outer here is y plus 1. So I think u sub will make it slightly easier. I'm going to put u being y minus 1. And we see du will be the same as dy, which is quite nice. And remember, these are the y values. When y is equal to 1, if you put it here, we get 0. So the integral will be 0 for the u. And then when you put 2 in here, we get u will be 1. And this is y plus 1, but u is y minus 1. So if you add 2 to both sides, that's u plus 2. And we get a u plus 2 being y plus 1. Yeah. And then times sine of u. And dy is the same as du. Okay. Now, to integrate this, we can do integration by parts. Of course, we can do the di method. So d and also the I plus minus plus. I'm going to differentiate u plus 2, and then I'm going to integrate sine u. So do this 1 time, 2 times, we get 0. We stop. And then integrating sine u, we get negative cosine u. Do this again, we get negative sine u. And then remember, this times this times this. 0 times nothing doesn't really matter. So, to continue, we will get u plus 2 times negative cosine u, so negative cosine u. And then negative 1 times negative, so it becomes plus sine u. And then at the end, we have to plug in 0 and 1. So, all this, 0 and 1. Okay, plugging 1 first. This here we have a negative, so we have a negative 3, and then cosine 1, and then plus sine 1. So far so good. And then we have to minus, plugging 0. Okay, 0 plus 2 is 2, and then cosine 0 is 1. So we have 2, and that's a negative 2. So negative 2. Plugging 0 into here, sine u 0, sine 0 is 0, so yeah, that's what we have. So negative is 2, so that's just negative 3 cosine 1 plus sine 1 plus 2. Yeah, that's it. The answer doesn't look any nice, but I think the integration process is pretty cool, especially it tests your understanding of all the essential integration techniques that you have to know. Hope this here helps. That's it.